Tomatoes. They're the essential ingredient in ketchup, pizza sauce, summer salads, and eaten all around the world. But with increasing global demand, how do we secure the future supply of this staple fruit? We believe the answer is automation. Large-scale greenhouses allow crops to be grown all year round. However, greenhouse growers struggle to keep up with the many tasks needed to supply their produce due to increasing labour shortages. The uniform layout of greenhouses provides a great opportunity to solve this shortage with automation. Pukekohe-based company FTech sees this opportunity and they have shared their vision with us. We envisage our final year project as part of a larger goal to create a commercially available autonomous system for completing greenhouse tasks. Our focus for the year has been automating the labour-intensive task of de-leafing tomato plants. This involves creating a modular device that will be mounted onto a separate robotic platform. We have outlined some constraints to deliver a proof of concept device, which we are calling Stage 1. Our base assumption is that a tomato plant is already in view of the camera. The camera view plane is parallel to the row of plants, and we are targeting the leaves within plus or minus 45 degrees of this plane. Our project has been separated into 3 areas, and these are vision, manipulation, and cutting.
The vision system acts as the eyes and the brain, with an overall aim of accurately detecting leaf stems and calculating their cut points. It sees the real world through an RGBD camera which captures colour and depth information. It communicates to the robot arm that moves the entire system and with the manipulator that drives the cutter. The system contains models that have been trained to detect leaf stems and main stems, and these are used to help calculate the cut point. Traditional image processing techniques are also used to make the final cut point identification.
Next, we have the manipulator, which acts as the physical link between the vision system and end effector. Firstly, it receives the target position through serial communication from the vision system, and this comes as a linear distance in millimeters and a cut angle in degrees. The manipulator can do both linear and rotational movements, so it then converts the target position into useful instructions for the stepper motors, including the speeds and accelerations to smoothly get into position. Once these instructions are calculated, it then powers on the motors and moves into the cut position.
The final part of our system is the cutting end effector. Once in the right position at a leaf stem node, this device cuts and grabs leaf stems. The grabbing and cutting mechanisms are actuated by the same drive shaft. The device first grabs around a leaf stem, centering it in the optimal position for the cutter. Next, the cutting levers are driven shut by 2 simple harmonic motion cams, and this forces the secateurs blades through the plant material. The grabbing mechanism may continue to hold the leaf stem, preventing it from falling to the greenhouse floor until the drive shaft returns to its start position and releases the gripper.
The system first goes through an initialization stage, which establishes communication with the robot arm, the manipulator, and the camera. It loads the detection models into the program and then homes the manipulator. The system takes a color image and uses a model to detect areas that contain leaf stems. The robot arm then moves into this region to have a closer look. If it really is a leaf stem, then the cut point can be calculated. The angle of the cutter is calculated in the same function as the cut position is calculated. Then the system moves the robot arm into place, sends the manipulator in, and makes the cut. Once the cut is complete, the robot arm moves back and starts the process again by looking for the next leaf stem. All movements have their real-world coordinates calculated using the depth information from the camera. Now that we have a system working on a 3D printed model plant as a proof of concept, the next stages will be continued by FTech, and we look forward to seeing how automation revolutionises the tomato growing game.
I'm Silvan.
I'm Brad.
I'm Sam, and this has been our final year project.